Okay, this is still lesson 6. It's the last part, which is the voltage divider. So I assume that you have gone through Kirchhoff's rules and all of those problems and things and figured all of that out. Now, we're going to spend just a little bit of time on this circuit called a voltage divider. And what we have is an input voltage, and we have two resistors, and then we have our voltage out. This voltage will come from our positive 15 volts and ground, and then this is what you'll be measuring with a meter. So it tells you in there to go through and solve for the resistance in series and use some of the techniques that you had used earlier to get the voltage, get an equation for this voltage out. So I will show you what you should end up with. So you should end up with V out equals V in times the quantity R2 over R1 plus R2. So if you have a voltage here and then you know your two resistors, then you can calculate what you should get for voltage out. Now a little bit more about the theory would be, maybe let me do this in red. Okay, this is all in black. There's nothing that says you have to have the voltage across the R that's called R2. You could measure voltage across R1. So I'm going to label this in red. Now, if you want the voltage across this R, then that V out is going to be V in, same V in. Then instead of R2 in the numerator, you'll have R1 in the numerator. The denominator will still be R1 plus R2. Now, one of the reasons, a reason for having a voltage divider is if you have a particular voltage available, but that's not what you want, then if you can find resistors that have the proper ratio, you can actually get a voltage that's different than what your voltage in is. So if you've only got a particular voltage available but you need something else, then you can use a voltage divider, assuming you can find the right resistances. Now, resistances, you can't just find any old values of resistances. There's a few kind of standard ones. There's a variety of values, but not every resistance is available. So if we look at the circuit, I've drawn the circuit over here on your circuit board. You're going to be using the 15 volt, the positive 15 volts, and you're going to be using the ground. You're going to have the two resistors, and notice which rows the connections are made in. And then this one is measuring across this second resistor. So if you call this R2, this would be V out across R2. And I would recommend using the orange meter. I think it's going to work best if you use the orange meter to measure voltages. If you wanted a different voltage, you could also measure the voltage across R1. And there's several things that it tells you to do when you actually set up the circuit. Remember that to get a particular voltage, there's a dial over here that you can change, and it will tell you what voltage to set that at. So you'll have to do that to begin with and then set up your circuit. Another comment about a voltage divider is there is a thing called a potentiometer, and the short version for that is a pot, which I am not particularly fond of that word, so I will use a potentiometer. There are a couple of those on the circuit board, but at the moment we're not going to use them. We might a little bit later. But to show you what that is, I'll just draw it down here. I don't think there's any place in the lab or the lesson that you need to write this, but you might write it on the back of a page or something just for your information. But notice when I was talking about the two resistors here, there are only certain values of resistors that are available, and if the available ones will not give you the voltage that you want, then you have a problem. So they invented a thing called a potentiometer, which is basically a variable resistor. So the circuit for that would look something like this. And what we do is just draw a rather long resistor and leave it with an end just open like that. So this would be Vn. And then we would have over here, this would come up here, and then we draw an arrow. And that's actually looks like it's in the middle. I'm going to change that a little bit. So we'll put it down here. Okay. So then you have a choice. Do you measure across here or do you measure up here? Well, the way I have it on my notes, I went ahead and drew the V out over here. So essentially what happens is this region becomes R1 and this region becomes R2. And these are usually enclosed so that you can't actually see the resistor itself there. But as you turn a knob, this arrow, this contact point moves. So it moves either up or down. And so if this were to move up, then R1 would get smaller and R2 would get larger. Still, the sum of those, the R1 plus R2, is the value of the potentiometer. The two on the circuit board, I think, are 1 kiloohm and maybe 10 kiloohms. And so you do have then a wide range of values that you can get because you can just turn the knob and this varies very slowly, so you can get exactly what numbers you would need. So we might use that at some point later, but I did want to mention it here since we're talking about a voltage divider. So the experiment for this is fairly short, mostly just to set this up and to see that you actually get what you're supposed to get with the resistors.